Hello, welcome once again into our next episode of partial fractions. We are going to take some examples on one linear quadratic as well as repeated quadratic factors. Let's go there. Today we are going to look at another example which involves the use of one linear and one quadratic factor. So to resolve this, we have 5x squared plus 3x plus 2 all over x plus 1 x squared plus 1. So we have equal to, recall our first example, x plus 1 plus bx plus c all over x squared plus 1. So notice the numerator we use here, bx plus c. This is because the denominator is a quadratic factor. Therefore, we are going to use a numerator that is 1 degree less than the denominator. So if we have x squared plus 1, then this one will be bx plus c. So if we have x cubed, then we know that this one will be bx squared. So that will now help to resolve this partial fraction. As usual, we need to multiply all through by the denominator. So if we multiply all through by this denominator to all the sides, we have 5x squared plus 3x plus 2 equal to a over x plus 1 multiplies this denominator, then x plus 1 will cancel this x plus 1, then we have this remaining. So we have x squared plus 1 plus bx plus c multiplying x plus 1. Then we have 5x squared plus 3x plus 2 equal to, now we have ax squared plus a plus bx squared plus bx plus cx plus c. So we obtain this by opening this bracket. So what do we have? We have 5x squared plus 3x plus 2 equal to, we can factorize a plus b x squared. We are factorizing those that have x squared terms, plus b plus c x plus a plus c. So we can also put this in brackets. So comparing terms, if we compare terms, we compare this, because 5, the coefficient of x squared is 5 and the coefficient of x squared here is a plus b. Therefore, we can say that 5 is equal to a plus b. Similarly, because the coefficient of x here is 3, the coefficient of x here is b plus c. So we can say 3 equal to b plus c, 2 equal to a plus c. So in this case, we can solve the system of equation. So we can say this is equation 1, this is equation 2, and this is equation 3. So from equation 1, we can say that b equals to 5 minus a. So if we go to question 2, equation 2 now becomes 3 equal to, we can now replace this b with this value. So we have 5 minus a plus c. So we have minus 2 equal to c minus a. So we can say that a equal to c plus 2. So our equation 3 now will become 2 equal to, instead of putting a, we can say c plus 2 plus c. So 2 minus 2 equals to 2c. So that means that c equals to 0 over 2, which is 0. So our a is c plus 2. We can say that our a is 0 plus 2, which is 2. And our b is 5 minus a. Our b is 5 minus 2, which is 3. So our a is equal to 2, b equal to 3, and c equal to 0. Hence, we go back into our equation, which says plus 1 equal to a over x plus 1 plus bx plus c over x squared plus 1. So this will now become 2 over x plus 1 plus 3x plus c. Our c is 0. So we have 3x over x squared plus 1. So we are asked to resolve this into its partial fractions. So to do this, we need to express this fraction into the form of its partial fraction. So we need to break it down to the possible form in which the partial fractions should appear. Without repeating the question, we have this is something as a over x plus bx plus c over x squared plus 2 plus dx plus e over x squared plus 2 all squared. Notice that we use x squared plus 2 all squared. We repeated this. This is because the factor is repeated. This quadratic factor is repeated. So one, we take a factor with 1 power less than the actual power. Then the other one will take the exact power of that, of the denominator of that quadratic factor. So next we multiply the fraction by this denominator. So if you multiply everything by denominator, you still have x power 4 plus 2x power 3 minus 3x. Then this is the same thing as if you multiply everything a over x by the denominator, you have a bracket x squared plus 2 all squared, then plus you multiply bx plus c over x squared plus 2 by this denominator, you still have bx plus c x squared plus 2. Then you have plus multiply dx plus e by the denominator, you have dx plus e times x. So we can now expand. We have x power 4 plus 2x power 3 minus 3x equal to a bracket x squared plus 2 x squared plus 2 plus bx squared plus cx. Just immediately we can just expand this first. So we have times x squared plus 2 plus dx squared plus ex. We can just open the brackets at once. So we have, this is the same thing as a bracket x power 4 plus x squared times 2, 2x squared, 2 times x squared, we have 2x squared, 2 times 2, we have 4, plus bx squared times x squared, we have bx power 4, bx squared times 2, you have 2bx squared, cx here times this x squared, you have cx power 3, cx times 2, you have 2cx plus dx squared plus ex. So this is the same thing as saying x power 4 plus 2x power 3 minus 3x equal to ax power 4 plus 4ax squared, because this plus this is 4x squared times a, 4ax squared plus 4a plus bx power 4 plus 2bx squared plus cx cubed plus 2cx plus dx squared plus ex. So we can compare terms. So for those that have power 4, we have x power 4 in the left hand side is 1, because this is 1x power 4, so we have 1 equal to, those that have power 4, we have a and the b. So for those that have x of power 3, which is this we have 2 equal to, power 3 is only c here, so we have c. So for those that have power 2, in this side there is no power 2, so we have 0 equal to, power 2 here is 4a plus 2b plus d. 4a, 2b and d. So for those that have x, we have minus 3 equal to, for x here you have this, which is 2c, and the ex, which is e. So for constants, there is no constant here, so we have 0 equal to, the only constant here is 4a. So if 0 is 4a, it means that a is 0 over 4, which is 0. If a is 0, from this equation here, it means that 1 is equal to 0 plus b. That means that b is equal to 1. And c equal to 2. From this equation, c is already 2. And from this particular equation, we can say minus 3 equal to 2c plus e. Minus 3 equals to 2. Our c is 2 plus e. So minus 3 minus 4 equals to e. So our e is equal to minus 7. However, from here, we can say that 0 equal to 4a, and our a is 0, plus 2b, our b is 1, plus d. So 0 equal to 2 plus d. So our d is minus 2. Therefore, a equal to 0, b equal to 1, c equal to 2, d equal to minus 2, and the e equal to minus 7. Our equation, which is a over x plus bx plus c over x squared plus 2 plus dx plus e over x squared plus 2 all squared, will now become, so we can just say 0 over x plus, our b is 1 times x plus 2, which is c, all over x squared plus 2, plus our d is minus 2x minus our e is 7 minus 7 over x squared plus 2 all squared. So this is the same thing as x plus 2 over x squared plus 2 minus 2x plus 7 over x squared plus 2 all squared. To check this, we can combine this fraction to see if we will get the same fraction here, this same fraction. So to check, let's say x plus 2 over x squared plus 2 minus 2x plus 7 over x squared plus 2 all squared. If we take the LCM of both sides, we have x squared plus 2 as the LCM. Now squared, x squared plus 2 squared. So we have this divides this, we have x plus 2 times x squared plus 2 will remain, minus this cancels this, we have 1 times this, we have 2x plus 7. So if we open bracket, we have x power 3 plus 2x plus 2x squared plus 4 minus 2x minus 7 all over x squared plus 2 all squared. So this is the same thing as x power 3 plus 2x squared plus 2x minus 2x is 0, plus 4 minus 7 is minus 3 over x squared plus 2 all squared. So we can decide to multiply by x over x, because x over x is 1, because this times 1 is the same fraction, so this is correct. So we can have x times this, we have x power 4, this times this, we have 2x power 3 minus x times minus 3, we have minus 3x all over x times x squared plus 2 all squared. So this is the fraction. So x power 4 plus 2x power 3 minus 3x over x plus x squared plus 2 all squared, which is the same thing as the same equation. So we have resolved this into its partial fraction. So we have checked, our check is correct, so our partial fraction is in order.